Good day, guys. I hope you are doing good. This is Elton from Maths and Science series. Before I continue with the video, I would like to actually bring this to your attention that as Maths and Science series, we offer two programs for those that are upgrading their physical sciences, mathematics, and life sciences results in phosphorus. We have Monday to Friday lessons for them, and second program is that we are offering physical sciences, mathematics, and life sciences to grade 10s, from grade 10 to grade 12 during weekend and school holidays. So now, guys, I'm going to show you how to prove the series formulas, the SN formulas. These formulas: Sn n over 2, 2a plus n minus 1d, and Sn equals a 1 minus r to the power n 1 minus r. So I'm going to show you guys how to prove these formulas, because you might find these questions in an exam. They want you to do what? To prove. So that's what I'm going to show you today. But before continuing, please make sure that you click on the subscribe button and make sure that you do what? You press the notification bell so that you can be notified when you upload new videos. So this is an arithmetic formula, or this is a linear number patterns formula representing all the linear patterns or arithmetic patterns. It is also known as the last term. Make sure that you know that. We know that Tn is the nth term, A is the first term, N is the term number, and D is the common difference. So let me show you how is A the first term. Where does N put? 1, since A is the first term. A plus 1 minus 1 D. Therefore T1 equals, here you're going to get 1 minus 1 is 0. 0 times D becomes 1. So I just showed you how is A the first term. Term 2, where does N substitute what? 2. 2 minus 1 D. Therefore T2 is A, 2 minus 1 is 1. 1 times D is D. T3, where does N substitute? 3. 3 minus 1 D. Therefore, it will be A, 2. 3 minus 1 is 2. 2 times D becomes 2D. Then T4 will be A plus 4 minus 1 D. A plus 3D. If we're asked to find T70, it will be T70 equals A plus 69D. T10, A plus 9D. T20, A plus 19D. T70, A plus 69D. T100, A plus 99D. I'm not sure if you understand the trend, but this is so important because we're going to use these things as we are proving those formulas. I'm not sure if you understand that. So it's so important. So let's prove this formula. Sn n over 2 2a plus n minus 1d. You know, this is an arithmetic series formula. That is why we actually started by introducing to you guys the arithmetic pattern from grade 10 and showing you how are we finding the first term, the second term, the third term, and the fourth term. Okay, so this is what you must know then. This formula, since it is called an arithmetic series, it works hand in hand with the arithmetic pattern or linear pattern. Okay, so let's prove this. It can be 4 to 6 marks in an exam. They will ask you to find this. So this video is actually for you guys to see how are we proving these formulas. Okay, let's get started. You start by doing this. Sn equals A plus, remember we are proving the arithmetic series. A plus D. A plus 2D. A plus 3D. Do you see this? Plus the last term. But let's do this. A plus n minus 3D. A plus n minus 2D. Oh, the D is outside the bracket, not inside. A plus n minus 1D. This is equation 1. This is equation 1. This is how we start doing this. So for us to find equation 2, this is what you must do. Equation 2, this is what you must do. You start at the end of equation 1 and you end in the beginning of equation 1 for us to find equation 2. That was so tricky, but this is what I'm saying. Start there. A plus n minus 1d, and you come with it as it is. A plus n minus 2d, we are here now. A plus n minus 3d plus, we are here. A plus 3d, a plus 2d, a plus d, a. This is equation 2. I hope you guys, you saw what I was doing here. Alright. Now this is what we're going to do. For us to continue here, you add equation 1 with equation 2, meaning that Sn plus Sn and everything in equation 1 you add it as it is with equation 2. So the first term here plus the first term, the second term here plus the second term, the third term here plus the third term. Okay, A, it will be A, this is the first term, and the first term here is this one. Okay, let me show you. This is the first term here, and this is the first term here. Alright, so the first term up there it's A, then down here it's A plus n minus 1d. You add them. This plus this is 2A plus n minus 1d. We can leave it like this because there are no common factors here. Then the first term in equation 1 plus the first term in equation 2 gave us what? Okay, Sn plus Sn. Remember we said that equation 1 plus equation 2. So the first term in equation 1 and the first term in equation 2 gave us 2a, gave us 2a plus n minus 1d. I'm not sure if you guys, you understand or you see what I'm trying to do here. Then let us put a cross in this one so that we can see that we are done with them. And the second term plus the second term. The first term in equation, the second term in equation 1 and the second term in equation 2. So this is the second term. A plus n minus 1d. Then you add. These plus these are like terms. We have 2a plus d. Now we can actually simplify this since we have the d here. Unlike on these first ones. So this times this is dn, d times -1 is negative d. No, this must be 2 here. Remember it is 2. It must be 2d. This times this is dn, this times this is negative 2d. So d and negative 2 are like terms. So we're going to have minus d plus dn. What do we see now? A common factor. So we can write it like n minus 1d. So that when we simplify it, d times n, it is positive dn, d times -1 is negative d. Do you see that, guys? And you can see that this is the same answer as what we got when we added the first term and the first term in equation 1 and equation 2. Meaning that as we continue to add this and this, this and this, we're going to get the same answers. So you do not continue writing them because everything that you're going to add up here and down here, you're going to get this 2a plus n minus 1d. So you leave it like this. Now, what you're going to do now, put an n here. Remember, the bracket tells us about what? Multiplication. It means that we don't know how many 2a's plus n minus 1d. We don't know how many of these do we have here. That's why we're saying that n number of whatever that we are having of these. I'm not sure if you understand that. Meaning that n times, if we had 2a, if we had 22a's plus n minus 1d, we're going to write 20 here. But now we don't know the number of 2a's plus n minus 1d. Therefore, we put what? N times this. Because everything that we're going to add is going to give us this. I'm not sure if you understand that. Now, let's continue. S plus Sn is going to give us Sn plus Sn, it is 2 Sn equals n 2a plus n minus 1d, close the bracket. Now we must make what the Sn, the subject of the formula, we divide by 2 both sides. I'm not sure if you understand that. Now, as we divide it by 2, this is what we have. Sn equals n 2a plus n minus 1d. And this is one the same thing as what I just wrote here. So you proved your formula. This is 4 to 6 marks. It depends on the mark allocation allocated by the examiner. So it's very, very important that you guys see or know how to do this. Very, very important. So let me show you how to prove the geometric one. But same thing applies. Okay, this is the geometric or exponential pattern, AR n minus 1. Let's show why or how the first term is A. So T1, A, 1 minus 1. It will be T1. Remember, R to the power 0 is 1. Therefore, A times 1 becomes A. This is the first term. I just showed you now how is T1 in a geometric or exponential pattern is T1 the first term. T2, AR2 minus 1. It will be AR to the power 1, which is AR. T3, AR3 minus 1 to the T3 AR squared. T4 AR4 minus 1, which is T4 is AR cubed. It's one and the same thing as what we're doing when we're actually showing you the arithmetic one. The exception here is that this one we are having exponents. So if we were asked to find T7, it will be T7 equals A to the power 6, T20 AR to the power 19. That's the only thing that differs. So we're going to use all of these as we are going to prove this formula. Sn A 1 minus R to the power n 1 minus R. And you must know that this formula is one and the same thing as Sn A R to the power n minus 1 R minus 1. It's one and the same thing. So in an exam, if they want you to solve this one, it's one and the same thing as this. So let me show you how to do it quickly. It will be Sn equals A plus AR plus AR squared plus AR cubed plus AR to the power n minus 3, AR to the power n minus 2, AR to the power n minus 1. This is equation 1. So how are we finding equation 2? For us to find equation 2, you multiply equation 1 by R, meaning that where there's equation 1, you multiply what R, you multiply whatever with an R. Rsn, meaning that where in equation 1 you multiply everything by R. A times R is AR. A times AR will be AR squared. I'm not sure if you guys understand this. You multiply this with an R, it will be AR cubed. AR cubed, this AR to the power 4 plus, you multiply this with an R, it will be AR n minus 3 plus 1, AR n minus 2, AR n minus 1 plus, AR n minus 2 plus 1, AR n minus 1. Then there you multiply with an R, it will be AR to the power n minus 1 plus 1, it will be AR. This is what we are having. This is equation 2. You multiply R in equation 1 to find equation 2. Then equation 1 minus equation 2. Okay, let's continue. Then you minus everything. Before a arc, do we have a? No, we don't. Therefore, a minus 0. It is, okay, Sn minus Rsn. A minus 0 because before a arc, we don't have a. So as in a alone, not attached to an r, we don't. So a minus 0, it is a. This minus this, you see, this minus this minus this, meaning that everything that you have in equation 1 must cancel equation, it must cancel whatever that we have in equation 2. So here it's equation, this is AR cubed, we do have it here. And since this positive sign, it tells us that the series is continuing, meaning that since we're saying that everything that you have in equation equation 1, it must cancel whatever that we have in equation 2 as we're doing. Since it is continuing, meaning that before this we do have AR to the power 4, so they will cancel. Plus, we do have something which is ARN minus 2 before this, so they will cancel. I'm not sure if you guys you understand that. Here it is. Even here, there's something that we are actually having. And what we have here, it must actually correspond with what you are having up there. So this will cancel whatever that looks like it in equation 2. This will cancel what? This here. But let us check here if we do have something like that. Remember here it has to be a r to the power n minus 1 plus 1, and this will cancel when we left with this. I forgot to put an r, but I just did. Then you can see that there's no plus. If there was a positive sign, we're going to say whatever that is similar to this in equation 1, we cancel this in equation 2. But since this is the last term, meaning that we have 0 minus this. So 0 minus this, it will be minus AR to the power n. This is what we are having, AR to the power n. I'm not sure if you guys, you understand this. And now what do we have? We have Sn minus, okay, we have a common factor here, which is Sn. That's our common factor. Therefore, our common factor is Sn. If we'll be left with 1 minus r, this is what we are having. So this time this is this time this is that. Equal to, we do have a what? A common factor, which is an a 1 minus r to the power n. And this time this is this time this is that. I'm not sure if you guys, you see what I'm trying to do here. Then you can make Sn the subject of the formula by dividing by 1 minus r. 1 minus r. Then we have a 1 minus r to the power n, 1 minus r. You are done proving that formula. So this is how you are doing it, guys. Make sure that you know this. So important. It's very, very important. So this is how we are proving those formulas. So we are done. Oh, okay, WhatsApp this number 067-875-806 or 8006 for more information for matric rewrites and for high school extra classes. So please do not forget to subscribe, guys. Please. Thank you.